Hi everyone, and welcome to this very simple and quick recording for what you can see here is oxidation and reduction. So let's begin. Simple half equation represent the oxidation and reduction happening in one reaction. Oxidation is loss of electrons, reduction is the gain of electrons. Let's revert back to the mnemonic oil rig. There we go. That should help us out. So let's move on quite swiftly. Now, oxidation numbers represent the charge on the atom if the bonding were completely ionic, irrespective if it is a covalent molecule or an ionic or a metallic or whatever. Okay, so let us carry on. In their standard states, oxidation is 0. We can skip all of this. I assume it's common knowledge. Group 1 atoms have the +1. That aluminium is +3 of course, but I just want to showcase that hydrogen is a +1 and that oxygen has a 2-. That's pretty self-explanatory. So let us move on swiftly. So during oxidation and reduction, the oxidation numbers of atoms change. If an atom is oxidized, its oxidation number increases. That's incredibly important. However, if it's reduced, it decreases from the left side of the reaction to the right side of the reaction. So let's keep reading. Sorry. So let's take a look at the steps to balance half equations. Method 1. Identify the atom being oxidized or reduced and make sure there are the same number of that atom on both sides by balancing. First, actually, I would balance the oxygen atoms by adding water to the right side. Then you balance the water by adding H+ ions on the left side. And finally, if there's any excess of charge, then you add the electrons. If its reduction is occurring, it's on the left, otherwise the electrons are put on the right. So let's take a look at this example here. So write a balanced half equation for the process of this here. So I'm gonna draw it right here at the bottom. So there we go. Becomes sulfate 2-. So let's count the sulfurs. So sulfurs both on two sides. Now here there are 3 oxygens and here there are 4. And so we need to add an oxygen on this side by adding water. Now we need to balance these 2 hydrogens here with H+ ions. Then we're going to count the total charge. So 2- and a plus here, 1+. Here we have neutral and 2-, and so we need to add an electron, I believe. Oh, I forgot to add a 2 here, that's a mistake. So that becomes 2+, and that becomes neutral. And so to balance this negative charge on here, that means it has 2 extra electrons on this side, 2-. That's what it really means. And so we're going to add 2 electrons on this side as well. So there you go. Let's look at another method. This does not use oxidation numbers and is easier in more complex processes. Identify the atom being oxidized or reduced and make sure there are the same number of that atom on both sides. So that's pretty self-explanatory. Then you add the oxygen. This is our method that I was mentioning earlier. Excellent. So let's practice this with an example here. So sulfuric acid to make hydrogen sulfide. Okay, so we're going to balance the number of. So first let's identify what atom is being oxidized, and so as you can see here, it's actually the sulfur being tossed around, and so we are going to work accordingly. Now there is only one S on here and only one S on there. And so we can move on to the oxygens. Now there are 4 oxygens here, so we'll need to add 2 water molecules on this side. Now to balance this, we have 4 hydrogens here, so we're going to add 4 H plus ions. Now let's count the charge. So this atom here is neutral. This is a 4 plus. This here is neutral, and so is this. This means it has 4 missing ions. So we're going to give it 4 electrons. And so that should balance the equation. What's the problem? Seems as though there's a problem. 4 H2O. 4. I see why. Okay, so yeah, I understand why, so we don't need to do that. But do read through this if you're watching this video for revision. Let's move on swiftly. The oxidation number of the S is decreasing and electrons are being gained. It is a reduction process. Reduction reactions. Half equations consider gain and loss of electrons. They can only be transferred from species to species. And oxidation is always accompanied by a reduction and vice versa. And this is known as a redox reaction. Okay, so we need to construct a redox reaction from an oxidation half equation and a reduction half equation. So let's take a look at an example of that. So H2SO4 plus H plus this. This is the Karen, open the door. Open it. H2SO4 plus 8H plus 8 electrons becomes hydrogen sulfide plus 4 H2O. Also in the oxidation we have 2 I minus becomes iodine plus 2 electrons. So let us try and insert it straight away into there. Okay, so 8H plus 2 iodine ions becomes hydrogen sulfide plus 4 H2O plus, from here we can see iodine diatomic molecule. So let's try and balance it. Now H2SO4 is neutral, 8H plus 8 plus charge. This has a 2 minus charge, so the total on the left side is a 6 plus. On the right side, this here is neutral, this here is neutral, and so is this. And so, to balance that, we need to remove not exactly sure how. Oh yes, we need to neutralize this 2 minus, and to do that we're gonna completely eliminate it by having the prefix 8, and this becomes 4, and there you go. Let's take a look at another example here. So aluminium 3 plus has 3 missing electrons, but now it's gained it back to become aluminium. 2 oxygen ions have 2 extra electrons each, and so they gave them away here. So Al3 plus, then we're going to insert this oxygen here, so plus 2O2 minus becomes Al plus O2. Now this here is a 3 plus, this here is a 4 minus. Okay, this here is neutral, entirely neutral. And so we're going to try and balance these charges out. The way to do this is to multiply this by 3 and to multiply this by 4. So multiply this by 3, this becomes wait, this becomes 6 on this side. So now it's 12 minus and 12 plus. Now that balances it on this side. However, now we have 4 aluminium here, so we're just going to balance it here. And now we have 6 oxygen here, so we're just going to balance it that way. And now it is balanced. So now we have constructed redox reactions, essentially. Now let's move on to oxidizing agents and reducing agents. The species which is reduced is accepting electrons, and thus itself is oxidized. Itself is reduced, and it is thus an oxidizing agent. These three from our 3 examples are oxidizing agents. The species which is oxidized is donating electrons to another species. Remember, oil oxidation is loss of electrons, so it's donating those electrons to another species, and thus causing it to be reduced. It is thus a reducing agent. There are some examples of reducing agents. Okay. So let's move on. A redox reaction here can thus be described as a transfer of electrons from a reducing agent to an oxidizing agent. Oxidizing is itself reduced, so gained, and is itself oxidized, so lost. Okay, let's take an example. Iodine plus 2 of this sulfur oxide, I don't know what you call it, gives these 2 things. So let us construct some half equations from it, shall we? Okay, so now I drew out the full equation, I should say. So now let us balance it. So let us identify the 2 species here. The first species here is the iodine. It is neutral here, and it's become an ion on this side. The sulfur oxide has now become a different form of sulfur. Okay, it seems as though it's remained the same. However, I doubt that. So let's start with iodine. Now that is quite easy. To become negative, it will have gained electrons, and so we're going to put 2 electrons here. Becomes 2 ion minus. So this here is reduction because it gained electrons. Now let's try this 6 with the charge 2 minus. Now as you can see here, and this has exactly double the number of this, so we can balance it that way. However, now we have a 4 minus charge here, and we have a 2 minus charge here. So this has 4 more electrons than this one, and so we're going to balance that out with 2 electrons on this side. Excelente. Let's move on. Iodine is the oxidizing agent. It is reduced itself, and this is the reducing agent. Let's take a look at another example here in this blue box. So sulfuric acid plus 8 H plus ions plus 8 iodine ions gives H2S, hydrogen sulfide, plus H2O plus 4 on 2. Now obviously here these are all neutral, however we do have lots and lots of charges here. However, they are balanced, and so let's take a look at the 2 species that one is being oxidized and the other is being reduced. Now obviously here it's missing electrons and it's now gained them here. It was missing them. It had 8 missing electrons, but now it's gained them. And so since it's gain of electrons, remember from oil rig, it itself is being reduced. Okay. So yeah, we're just gonna put 8 electrons, and it's now become, where has it gone? It's gone to 2 products, H2S and H2O. Okay, so let's now balance them. So we have 8 here, and we have a sulfur and oxygen here. So where did they come from? Of course they came from this. So let's add a sulfuric acid. So now let's try and balance the numbers out. So as we can see here, okay, 8 hydrogens and another 2, so that makes 10. 4 oxygens here, so let's try that. 8, 2, okay. Once this, excellent. Now let's try and handle the charges. Oh, actually, this is done. Excellent. So now let's take a look at the other species that is being handled here. So we have 8 iodide ions becomes 4 iodine diatomic molecules, and so 8 Am minus becomes since it has 8 extra electrons, it's going to give it away, and now it's going to become the diatomic molecule that it was. Iodine, this is iodine, but now we can simplify this. 884, they do have a common factor, and so we're going to make it's 2I minus 2 electrons plus iodine. So let us confirm that this is all good. Yes, it is. Okay, so let us move on to the 6th topic here. We're almost halfway, guys. So, disproportionation. So, some substances undergo both oxidation and reduction, and therefore are both oxidizing and reducing agents. So, hydrogen oxide, I don't know what you call this, and chlorate ions are 2 examples. Okay, now let's take a look at this here. Let's analyze it. So I'm going to use my purple highlight. Hydrogen here, okay, and hydrogen plus ions. Now it's become neutral, so I gained electrons here, and since it's gain of electrons, it is reduction. However, it has lost electrons in this case. I don't quite understand this actually. Chlorate plus 2H plus 2. Okay, let's try the first example. Hydrogen oxide plus 2H plus ions becomes this. Now obviously we can see here that there's been a 2 plus this, so obviously it's going to be reduction. And since there are 2 electrons on the other side of the equation, it has been oxidized. And hence disproportionation. I don't know. Properties of group 2 metals. This is very nice. Now obviously they are called alkali earth metals, and they are all reactive metals. Magnesium and calcium are abundant in the Earth's crust. The others are relatively rare. Group 2 elements of the outer shell configuration of these. Properties of individual atoms, atomic size. So as you go down the group, more energy levels, so more shielding, more repulsion,